And so I'll introduce Dr. Daniel Janies, and he will take it away.
Hi, thanks, Jessica, and thanks for your um, introduction, and thanks to all the attendees for coming. Um, I've been asked to talk a little about what CIPHER is. This talk is about career progress, but just to break the ice, CIPHER is a center. It's not an academic department. We are only doing research here. We each, all the faculty that work here, each have a home department in which their academic affairs life takes place. Their tenure and promotion is evaluated. They do their teaching. Their students are matriculated in classes in their home departments. But a center brings together different departments. For example, in CIPHER, we have biological sciences, bioinformatics and genomics, and public health. And the idea is that to build a team science atmosphere, and I'll talk about a little bit about that later, but the idea is that we're all experts in different kinds of pathogens, bacteria, viruses, even the animals that carry them, bats and mosquitoes and ticks and so forth. But we share the viewpoints or the approaches of computation and genomics. So we do a lot of DNA sequencing. Now we're segueing into proteins and protein structure using artificial intelligence. And it's all aimed at, our mission is to abate infectious diseases of all sorts, okay? So segueing back to the topic at hand, I found a Nature article and I screenshot it. The URL is at the bottom, and it's longer than this snippet here. In the article, and there's a series of articles at that URL, it's about how to find meaning in a science career. Science is hard. You're not gonna make money right away. You're gonna suffer long hours and for low pay, but so you have to really want it. You have to really want to do it. All right. So they asked Nature, as a leading magazine out of the UK, and it covers science and science news and the culture of science. They asked philosophers, social scientists, and a Nobel Prize-winning economist how researchers can pursue work that makes a positive difference to the world. Here are their top tips. And I use this as an outline for the rest of my talk, putting getting away from Nature and putting my own experience to it. So you have to think about turning what you love into something that's beneficial to the world. You have to choose a pressing problem. If you go to the URL, they list some, but there's more than what Nature says. Be ready to work behind the scenes with policymakers, even though you might get no credit. I thought that was interesting in there because it's never taught in STEM, although it appears. And I've had some experience with that, and it's been one of the biggest exciting opportunities I had outside of the lab. Observe where early career researchers you admire are putting their energies. I would say observe everybody. It doesn't have to be early career or late career. And the way we run the team science atmosphere here is everybody should be learning from everybody all the time, okay? Whether you're younger or older, people have all different skill sets, and the idea is that we put those skill sets together and develop synergies that are more than the sum of the parts to solve difficult problems. That's the essence of team science. Keep sight of the big picture. A dreary lab role might feel meaningful if you focus on the ultimate goal. I'll talk about some self-organizational techniques along those lines. Yeah, and like all things that are worth doing, expect to work hard but also appreciate the role of timing and a chance. And to me, that's when opportunity knocks. Try not to ignore it, okay? And try to take advantage of opportunities and be prepared for opportunities. So there's a phrase in American English, some people are good at making their own luck, right? So let's break this down in terms of the benefits. What are you benefiting with your work? Why is this subject important? Ask yourself that. Be able to explain it to a person in the grocery store, all right? So who doesn't have all the scientific training that you have. What's hot now is, of course, artificial intelligence, and that can be applied in all arenas, making work faster, better, at larger scale. And we're definitely doing that in the sciences. Energy is always important. We're transitioning from fossil fuels, but it takes a lot of innovation to do so. And so fossil fuels remain, a very large fraction of what we use for energy, and nothing happens without energy. In the United States now, we are realizing, among many areas of supply chains, that one of our pinch points are critical minerals. These are rare earth elements and other minerals. They're important in manufacturing, your computer, your cell phone, fighter jets, your car. Largely, a lot of them associated with magnets. And they're not rare. I talked to some geologists. They're not rare in the earth. They occur everywhere. It's just economically mining and processing them. It has been almost exclusively developed in China, and so it's being used as a geopolitical lever. And so those fields in the United States, among others, will be critically important too, as not only driving the economy, which is basically technology based, but also national defense. And so the U.S. government is investing directly in some mines and processes development and workforce development in that area. Similarly, in healthcare, we all learned how poorly we were prepared during the pandemic, and it was bad, no doubt about it, but it could have been worse, okay? And so I often think of a speech I heard by Treasury Secretary Bessent that in essence, the SARS-CoV-2 pandemic was a test, and it showed how weak we are in our healthcare supply chains. We didn't have enough masks, for example. We didn't have drugs ready to treat a novel virus. And so we're also going to try to onshore more health innovation. There's less direct investment right now. There's a little bit of a cross purposes conversation in Washington right now about how best to prepare. So it's not as clear a path as the critical minerals path, but anybody who knows, if you're young and healthy and you never hurt yourself, you'll learn one day that having access to good medicine, and I mean good practice of medicine, is critically important, and we have to maintain that. Not just infectious disease, but cancer, all aspects of medicine. So I can pause there, or I can move on. Any questions? Okay. Once you define a problem, what is it? What's the problem? And in science, you don't want to reinvent the wheel. You want to know everything about a problem. There's a lot of homework, there's a lot of reading. And then once you identify a problem, what's left to do about it? Can you do something about it? I mean, I can probably think of a few problems that I'm not in a position to manage as a college professor. But let's say you do find a gap, something that can be added to the conversation, or when I work with young people, I often say, I teach a class in which we see a lot of talks by scientists, and then I flip the classroom and I ask them to give a talk. And if they don't have a topic they're working on, they're not working on a thesis yet or anything like that, I say, well, read the literature and why don't you find a problem that there's two sides? Often there's two sides of argument. School of thought A and school of thought B, okay? And why don't you ask yourself, what's the key experiment to adjudicate this two schools of thought? And it could be one wins, one loses, or it could be that it's a blend, that they each have part of the solution to the problem. So define your solution. What does success look like? Or what skills do you need to approach the solution, and what key experiments do you need to do? And then define success. And hopefully do it before, or at least have a vision of what it might be so you can work towards it, and ask how your solution changed the world. I mean, a lot of academic papers are criticized because nobody reads them, right? So I think we can't afford to do that anymore. We have to do things that not just because we're curious. Curiosity is great, but curiosity plus something useful is better, Policy and press. Okay, Nature talked about policy, and they didn't talk about press. Well, they are the press, so that would be a little self-reflective, I guess. I've had the opportunity to brief both the Senate and the House of Representatives and President Obama's White House on infectious disease. Through that, I learned we do have people who handle government relations for the university. So if you are put in that situation in a company or the university, definitely seek the advice of the professionals. Handling yourself in front of policymakers is a really important skill to learn. You don't want to approach it the wrong way, okay? So the basic rule of thumb is you're offering subject matter advice, and they're not dumb, okay? So you're offering advice on the science, okay? You're not offering, you didn't get elected. You're not offering moral advice or policy advice. They're the ones who got elected, okay? And then in terms of the press, you write good papers, okay? We write formal papers that explain the introduction, the methods, the results, and the discussion. And if you're honest, some weaknesses about the experiments and what the next steps might be to abate those weaknesses. But when you're talking to humans, I often tell my students, you have to express your stories in plain language. And these are related. I don't want to speak down to the senator. I don't want to speak down to the man in Food Lion. But I want to express my English in a way that they can understand what the problem was and what the solution was, and why it's useful, and why the taxpayers should support it. This kind of work, okay? Nature speaks of observation of success, and I took out the just follow young people. Just ask yourself, who do you think is doing something good? Maybe you find them in the newspaper, you find them on YouTube. What are they doing? And I bet you it will have these properties. What they're doing is likely novel, and they're among the first to do it. It's likely not easy, okay? If it was easy, somebody would have done it already, right? And I'll add that problems are very complex now. Infectious disease, for example, has aspects of zoology, zoonotic disease. The animals carry bacteria and viruses to us 70% of the time, okay? It has aspects of environment. It has aspects of sociology, people interacting with animals through overpopulation and expansion of cities into rural areas. It has agriculture. Sometimes zoonotic events, a virus or bacteria going from animal to human, happens on a farm. And then when you have to kill all the farm animals, like avian influenza infecting flocks of egg-laying hens, the price of eggs goes up. So it has economics. So these modern problems are very complicated, and that's why we invoke the team science ethos. Plus, doing research is educational in that we can interact and inform each other, share our skills in a multi-lane highway, and that's what CIPHER is. Okay, it's not just a, well, you call it a two-way street, three-way street. It's a complex highway, and that's what we're involved in doing here.
Dr. Janies,
Yeah,
there's a question in the chat from a
great.
student. Heba asks, do you believe that the use of AI is beneficial for the current and future research field?
Yes, definitely so. Just as a for example, we took the raw sequence information from the SARS-CoV-2 Omicron when it first came out, the Omicron variant. And within a matter of days, we used artificial intelligence to fold its protein and then used artificial intelligence to compare the new protein, because the virus had mutated, to existing antibodies in your body that you were elicited through vaccination or previous infection. And we saw that there was a mismatch, that the existing antibodies weren't going to fight that virus. So we were able to model using AI breakthrough infection within a matter of days, whereas this would have taken months in the lab, and the Omicron wave would have swept the country already, and there was no warning and no understanding of why it was sweeping the country, and no understanding that the vaccine needed to be reformulated. So that's a really poignant example. Day to day, we're processing big data sets, huge, just rows and rows of Excel spreadsheets that AI is really good at summarizing and finding patterns in. Okay. Yeah, just any way you can accelerate your work, check it. Don't take it as an oracle. It's not telling you the truth. It's just organizing things. Okay. It's really just statistics on steroids. Okay. Don't be afraid of it. And if you don't do it, you're going to get beat by somebody who's doing it. Science is,
There's
yeah, I left this out. It's competitive, yeah.
there's another student, Abby asks, what about generative AI, such as assistance in writing reports, papers?
Yeah, you have to be ethical about it, though. I mean, you don't want to. It all started with, um, this has been going on for a long time. You always want to give credit where credit was due. So, you always want to write your methods in the paper, how you did things, and you want to be kind of like very explicit about it, like, not only I use program X, but I use program X under these conditions. We even write down the kind of CPU it ran on and all this. So to me, yeah, generative AI or AI can be a tool to process information, organize your thoughts into reasonable paragraphs, but don't look for it. Don't look to it for the solution. It's it's Google on steroids, right? So look for it to help you move faster. If you write a paragraph with it, edit it. It makes mistakes all the time. And you could get burned by those mistakes if you don't edit it. So it can help you move faster, but you have to check and you have to make the words your own, okay?
Um, there is a question from Trinity. Are researchers typically paid through their associated organization or through federal funding?
Some of each. It's a blend. If you work for UNC Charlotte, you have a 9-month salary. If you're a tenure track faculty member, and that's tied to the academic calendar. And then if you have federal funding, you can use that in the summer, or industry funding, you could use that in the summer. And so that's a typical model. Okay. In some other places, there's a requirement that faculty recover their salary from federal awards. I don't know how that's going to work. That business model seems to have broken in 2025. So, um, yeah. So just be very aware of what we call the hardness of your salary money. the more and more you rely on grants and contracts, which are ephemeral, that softens your security. Whereas working for a university in a good state with a good management like North Carolina is very important these days. Yeah.
And our director says, Dr. Janies, if we don't use it, then we probably won't get that same money the next year. So is that the same rule applies to your department as well?
I handle a budget just for the center. I don't handle the budgets for the academic departments. So that's a better question for a department chair or dean. Yeah.
Well, typically, just I don't know if a lot of students know, but most departments, when you get a budget and you spend less than that amount that year, then they're going to give you the lesser amount typically the next year because they say, oh, we over budgeted. So most of the time, departments, when you get a budget, you want to try to use all of it. So you get that same amount, possibly the next year.
Yeah.
All right. So Dr. Janies, I think we're good with questions at the moment, so you can continue on.
Okay, great. So I just want to talk about the big picture. Yeah, things worth doing are not easy, all right? So science can be repetitive. You might have to repeat experiments. They might not work. They might be long. You might have to come in. You definitely have to work weekends. When I was young, before I had children, I worked every weekend. I work evenings too. But the most important thing is you're doing experiments that you can interpret. Don't spin your wheels. I tell my students all the time. If something didn't work, okay, let's break it down. Let's learn from the mistakes. What didn't work in that experiment, and what are we going to do different? And don't change everything at once. If we can pinpoint that it was just one chemical that was bad, don't change two chemicals. Change that one so you can interpret the results. But also, man, not everything's a mistake. Serendipity is good in science. Be prepared for unexpected results that don't fit your early mental model. It's actually quite important to not be dogged about a mental model going into experiments, so you can be ready to perceive unexpected results. Let nature take its course. And when the data builds up that your perceptions, preconceptions might be wrong, be prepared to have your mind changed by data. Okay. And it's also important. The flip side of that is to be healthily skeptical. I've had results that were very good in the first experiment, and a famous professor said to me, okay, now ask yourself what's wrong with it. And I thought that was a really good lesson. Work hard and bear in mind that timing and chance matters. Work at projects that have clear goals. And this is a technique that I like. Set reasonable short-term goals for every day. Even make appointments for yourself on your calendar or lists. Write them down. It's not hard to do. And set long-term goals in which the short-term goals are the steps. Okay. We have a structure for scientific papers of introduction, methods, results, discussion. Those are all short-term projects. And when you have a big project, it does help you psychologically to break it into small component parts. Okay. And then when you're tired, do the stupid things like format the references or draw no, it's stupid, but do the mundane things like clean the lab or balance your checkbook, all the things you have to do. So you can be fresh the next day. And I find doing harder things in the morning is better. Okay. And doing, mundane things in the afternoon and evening is better, just to take advantage of the freshness of your brain. And then when opportunity knocks, be prepared to pivot. I was a natural science student through my postdoctoral years. And then I got a job opportunity to join a medical school at Ohio State University. And, it wasn't comfortable, but, I understood medicine. I admired medicine. I just didn't feel like I was necessarily right for it. But then the opportunity came and I went and I learned a lot, and I pivoted to infectious disease because the skills I had from natural sciences mapped over to it. And it's been really great. And that URL I showed in the beginning, there is an article about changing careers within the sciences, and there's, you know, there is a ramping up period, and there's a way to do it. And there is a, you know, you have to go downhill a little first before you go back uphill. In short, okay. But a lot of the world's like that. Okay. And I'm done. I'm wide open for questions. Thanks for all your questions so far, and your kind attention.
So Dr. Janies, you mentioned you worked closely with President Obama, or
No,
you
no,
are
so you go there. Can I tell the story? It's a good story.
Sure.
Okay, so I published a paper, and somebody in the attached to the White House saw it. She was providing briefings periodically on infectious disease threats. And I got to know her. She called me, and I got to know her. And she said, "Hey, I was just in a meeting, and they want to know about you, more about your paper. How's Wednesday sound?" And I was like, "Okay, yeah." And I was like, "Are they going to send me an invite? Who do I call?" And they're like, just be around, and we'll we don't want to set a time. We'll find you." Okay. So I just went to DC and checked into a hotel and turned the ringer on my cell phone and sat there until it rang. And then I walked over, not to the White House per se, to the executive office building. If you go to DC, they look like these French buildings. It's and they're these tiny offices. It's, 19th century building, these tiny offices. And I had PowerPoint ready. I didn't really use it. I had kind of learned that they don't want PowerPoint. They just want to hear from you. So I walked into the Office of Medical Preparedness, and five guys, and this was the time of BlackBerry. The five guys are typing on their BlackBerries. "Yes, Dr. Janice. Yes, thank you." And they asked me a few questions. At this time, we were in the pandemic of H1N1 influenza, and they asked me a few questions about it. And then they said, "Okay, you can leave now. Thank you very much." And that was it. That was it. So I saw the inner workings of the policy mechanism of the White House. Yeah.
Gotcha. And we do have another question in the chat from Lindsay. Dr. Janies, what were your career aspirations before you took the med school position and eventually pivoted to infectious disease?
Oh, I wanted to be a professor. And I am. I achieved it. I just the content of what I was working on, and the importance, I would argue too, was very important. And so, yeah, I didn't deviate in terms of career goals. I deviated in terms of subject matter. Okay.
And then Heba asked, is there a biological research field that currently has a lot of demand?
Yeah. I would say anything to do of where there's a practical outcome, like applying AI in drug development, applying AI and improving clinical workflows. That means how people are processed through medical offices. There's an area of clinical informatics that all my, medical records, all my friends who work in that area are tremendously in demand. And I think AI will finally allow them to use the clinical corpora, all the clinical information stored in databases, to its full potential to do research, to do informatics-based research, to improve medicine itself. And then, yeah. So any improvements or efficiencies that AI can bring in delivering care and improving the efficacy and cost efficiency of care are all very important.
Dr. Janies, do you hire students to work with you, to do research with you? What if a student wanted to do that? What would you recommend maybe their first steps be?
Well, there are many ways to get funded to do it. We at UNC Charlotte, we self-fund many programs. One is the Career Center's UPIP program, University Professional Internship Program, that I've happily participated in for a number of years. I started to work with the Office of Undergraduate Research as well. And the most important thing is you get to know a faculty member from class, or you do a project with them for credit, and then once they realize it's a good working relationship, they can do, it's a pretty simple application. They can do an application and suggest projects through these um, uh, programs, and then you apply to those projects, okay, at the undergraduate level. Graduate level is another ball of wax.
Gotcha. All right, great, thanks. And we do have another question from a student in the chat. Quinn asks, as someone actively looking for any type of research role accessible, what advice would you give someone struggling to break into the field in this current job market? Should I lean into adapting my research background to AI applications for resume purposes, like you mentioned?
Yeah, it depends what your field's looking for. AI definitely gives you a leg up, but sometimes when I see resumes, I see all the right buzzwords, but I don't see any outcomes. I don't see any publications. I don't, I don't see any products. So definitely don't just put all the buzzwords on your resume. Put little narratives like I used AI this way and we produced this paper or this poster, or I got invited to this student conference or so forth. I want to see actions and results. Okay.
Gotcha. And we do have another question. Heba asks, how do you start to network with other professors and research professionals?
Well, we have conferences. We write each other emails a lot. Yeah. And there's a famous guy I want to get to know. And I saw him at the airport because we were flying to the same conference. And so I said, well, he's trapped here waiting for it to get on the plane. He's got nothing better to do than talk to me. So I went and talked to him. It was good. So don't be shy. I was shy growing up and I got over it. So it does hold you back. Yeah.
Yeah, when you're trying to actively seek research opportunities or even work opportunities, anything like that, you kind of have to put your fear aside and just go out there and tell people about yourself and what you're doing, what you're looking for,
Yeah.
because you don't know who you're talking to and who you might meet.
Yeah. And it doesn't hurt to have business cards, even if you don't have a job. Just get them made for yourself, something professional, something nice with your contact information. I find that people don't write you back right away unless they want to sell you something. So I typically end a conversation with an excuse, for lack of a better word, or a reason, I should say, to write them. Say, oh, by the way, I wrote this thing, this paper on blah, blah, blah. Um, I think you might be interested in it. May I send it to you Monday? And then you can get the ball rolling with a little email, or I'd like to follow up. Can I? And for somebody who's busy and important, one of the tricks is getting their assistant's contact information, because then you can bother that assistant a lot, and then that assistant can, if you're nice enough, can find a way to get you on the person's schedule. Okay.
And Dr. Janey's like, would you say that if a student seeked out saw your research online and found your email and they emailed you and say, hey, could I schedule a meeting with you? I just want to talk about the research you're doing. Would that be something that you would be
Yeah, yeah,
receptive to?
yeah, very much so. We get a lot of spam type emails where somebody's writing all the professors, 100 of them, the same email, and they sometimes don't even change the salutation and greeting. So don't do that. If you're really interested, maybe read a little what the person did and said, hey, I really liked your paper on XYZ. I'm a student here at UNC Charlotte. If you're from somewhere else, I may or may not, be very enthusiastic about you. But if you're from UNC Charlotte, it's my job to talk to you, and not all learning happens in the classroom. So.
And also, I just wanted to mention, I kind of networked with Dr. Janies, and that's how he agreed to do this for us. I saw him speak at an event that I attended, and I instantly reached out to him, and that's how he is here today. So
Yeah,
it was
great.
through
That's a
networking
good
as
story.
well. And you
Yeah.
can see that. That's why I asked you all students if you were able to turn on your camera, because this is a way of networking as well. You're connecting with a professor that is doing research here on campus, and he is seeing your face and you're asking him questions, and so he sees that, and this is a way of networking. You can network on LinkedIn. We do a lot of that. I do a lot of that. You can network with professionals at research conferences like Dr. Janie's mentioned. We have lots of events through different departments. I'm sure your department encourages some types of events where you bring in alumni, professionals, things like that, companies, recruiters. So tons of events throughout campus, virtual, in person, tons of way to do that. And also there are also events that, wouldn't you say, Dr. Janies, those networking types of events that aren't planned, but maybe you're at the grocery store or you're in line somewhere and you happen to talk to someone. I've heard of this happen to students and other people, and it turns out they're talking to someone that is a researcher at this company that they've always dreamed of working at, and something happens. So there's all different ways of networking. So I would always say, like Dr. Janies mentioned, be able to pivot, be ready. And you're always kind of marketing yourself wherever you go.
Yeah. Yeah, that's all really good advice. We have in CIPHER a coffee hour, I think every other Thursday. If you email me, I'll get you the information. And sometimes there's a talk, but it's a very informal session where I have students that are attached to me through their, formal programs, but it's a chance for us to talk to people that are not formally attached to us. Okay.
Um, there's a question from Art. Is there a good way to learn how to write a research paper? Best practices, things to do and not to do.
Yeah. Well, by hook or crook, you gotta learn it by doing it. In my class, 4600, we write abstracts, and that's just the beginning. And there are some rules. Science can be mysterious. I'll help you break down that mystery. But yeah, and there's some structures. First thing to do is you have a target journal, and they'll have an instructions to authors there. And then you can look at papers you admire out of the journal and emulate them. I mean, yeah, so you can emulate people, but emulate reasonable papers too. One of the things that I really have learned is that short papers are good. Long papers don't count more. um, a lot of what we're doing now is writing a short paper and putting a lot of the raw data into what's called supplemental materials, like an appendix. Um, the structure of DNA paper, Watson and Crick, 1946, was 2 pages. Remember that.
And I saw on your website that CIPHER has a podcast.
Oh yeah, yeah. So you can learn. You can sort of virtually meet the faculty that way too, and we talk about their sort of professional journeys in those podcasts as well, and why they care about what they're doing. So yeah, it's very much rhymes with the content of my talk today.
All right, last chance to ask your question here today at this session. If not, I encourage you to reach out to Dr. Janies, and if you have additional questions. Oh, Art asked if they can get a copy of the presentation. Well, you can, but we've recorded this session today, and we will be uploading it to the Career Center YouTube channel.
Great.
And then where can I listen to podcasts? So the CIPHER website. So I'm gonna put it in the chat right now. If you scroll down, you can see, check out the CIPHER podcast, and there'll
Yeah.
be links there.
It's called Deciphering Infectious Diseases.
The YouTube channel, actually, if you, our YouTube channel, let me go ahead and, it's the Career Center at UNC Charlotte, and you'll be able to find it. Just give me a day or two to upload it, and you'll be able to find it. The Nature article. So Abby has already read the Nature article that you provided the link for, Dr. Janies, and she said that it was a very good article, so she thanks you.
Great. Oh, you're all welcome.
Oh, she skimmed it.
Okay.
Well, great. Thank you for looking into that, Abby. And hopefully everyone else will go look at that article, maybe listen to a few podcasts. And then if you wanted to get more details and go and look back at this presentation, it will be up on our YouTube channel from the Career Center. So let's everybody thank Dr. Janies for sharing this information and answering everyone's questions today. And thank you all for attending.
Okay, great.
Thank you.
Thanks a lot. Bye now.
Bye.